Okay, this is the key to the extra practice that I attached on the website that says Module 9 quiz ready to go on. This is actually from your textbook. It's page 312 if you want to open the online textbook. So ready to go on. I'm not going to write the problem in the interest of making this video short enough to upload. So you need to look at the problem as I'm doing these. And you can always pause to compare my answers or my work to what you did when you were doing the problem. So first one, give the value of x, find the value of x, give the answer in simplest radical form. The 5 and the 9 are the legs of that right triangle because they meet at the right angle. So 5 squared plus 9 squared equals x squared. 25 plus 81 equals x squared. That means 106 equals x squared. So I have to take the square root of both sides here, and I will get x is the square root of 106. So now I'm looking for the biggest perfect square that goes into 106. That's numbers like 4, 9, 16, 25, 36, and so on. The biggest perfect square that goes into 106, I don't even know if there is one that goes into it. Let's see. It's not divisible by 4. It's not divisible by 9. It's not divisible by 16. It's not divisible by 25 or by 36 or by 49 or by 64 or by 81. So this is my answer. Number 20. Number 2. Woo. Jump from 1 to 20. Find the missing side length. Tell if the side lengths form a Pythagorean triple. Explain. So I have 9 is one of the legs. The 11 is the hypotenuse. It's not a leg. So I have 9 squared plus, we don't know what squared equals 11 squared. So 81, I'm calling it x squared equals 121. So x squared is 40. So x is the square root of 40. Biggest perfect square that goes into that is 4. 40 is 4 times 10. Square root of 4 is 2. So 2 root 10 is what I get for my answer. This is definitely not a Pythagorean triple because that's not a whole number answer. Okay? If you have a radical or a decimal, not a whole number. Number 3, tell if the measures 10, 12, and 16 can be the side lengths of a triangle. We didn't talk about that, so I'll tell you right now they can. The next part we do talk about here, and that is classify it as acute, obtuse, or right. 10, 12, and 16. Remember, I take the two smaller sides and square them and add them. This becomes my A and my B. So I have 100 plus 144, that's 244. This side is the biggest side is my C. I square it. I believe that's going to be 256, but let me double check. And it is. 16 squared gives me 256. I'm comparing this number to this number. This is the C squared. This is A squared plus B squared. In this case, C squared is bigger than A squared plus B squared, so this is an obtuse triangle. Number 4, a landscaper wants to place a stone walkway from one corner of the rectangular lawn to the opposite corner. What will be the length of the walkway? They're asking me for the hypotenuse. We have 50 feet here, 80 feet here. I'm going to do 80 feet squared plus 50 squared. And it says round to the nearest inch. So that means to the, well actually, that's kind of going to be difficult. Not too difficult. Let's see. We have 80 squared plus 50 squared equals 8,900. Take the square root of that. And you get 94.339 or 94.34. Here's the deal, that's in feet. This was in feet, this was in feet. If they want me to round to the nearest inch, I have to take this and say there's 12 inches in each foot. So if I want to have like 94 feet and some odd inches, I'm going to say 0.34 of a foot is how many inches out of 12. So 0.34 times 12, that's about 4 inches. So I did 0.34 times 12 to get the 4. So 94 feet, 4 inches is my answer. Number 5, find the missing side length. Tell if the sides form a Pythagorean triple. I can already answer. They don't because look, I've got decimals already. The problem has decimals in it. The problem says x is a leg, 4.5 is a leg, and 7.5 is my hypotenuse. So I'm going to square 4.5 and 7.5. When I square 4.5, I get 20.25. When I square 7.5, I get 56.25. And I'm going to subtract. So I get x squared equals 36. X is 6. So x is a whole number, but 4.5 is not, and neither is 7.5. So it's still not a Pythagorean triple. Number 6. I have the two legs there. 24 and 32 are legs. So I'm just going to do 24 squared plus 32 squared. That's 1600, and when I take the square root of that, I get 40. So x equals 40. If I have three sides and they are 24, 32, and 40, all of those are whole numbers. So yes, that's a Pythagorean triple. Number 7 through 10, remember I said don't worry about whether it can be a triangle or not. I'll tell you right now that number 7 can. And I just have to figure out acute, obtuse, or right. So I'm going to do 9 squared plus 12 squared. 9 squared plus 12 squared gives me 225. 16 squared gives me 256. Remember, if your c squared is bigger, then that's obtuse. Number 8. 11, 14, and 27. Those can't be the sides of a triangle, so I'm not going to do that one. The reason I know it can't be the sides of the triangle is because 11 plus 14 is not bigger than 27, so it can't work. So forget that one. Don't worry about that, though. Again, we did not talk about that. Number 9, those can be the sides of the triangle, 1.5, 3.6, and 3.9. So we have 1.5 squared plus 3.6 squared, and that gives me 15.21 for these two. And then over here, my c squared, 3.9 squared, is also 15.21. So guess what? If those are equal, that's a right triangle. Remember that if it works for the Pythagorean theorem, if a squared plus b squared is equal to c squared, that's the definition of Pythagorean theorem, basically. You've got a Pythagorean theorem. If the Pythagorean theorem works, excuse me, you've got a right triangle. So here we have 2, 3.7, 4.1. These three can be the sides of a right triangle. The sides of a triangle. Let's just see about whether or not it can be right. 2 squared plus 3.7 squared is 17.69. 4.1 squared is 16.81. So here my c squared is smaller than my a squared plus b squared, so that's an acute triangle. That's number 10. Now in 11 through 19, we are looking at the rules for special right triangles. Remember that on special right triangles, you've got two types of triangles. One is a 45, 45, 90. The other is a 30, 60, 90. If it's a 45, 45, 90, there's only one number to worry about, and that number is square root of 2. The hypotenuse is a square root of 2 times either one of the legs. If you're going backwards from the hypotenuse, you would just divide instead of multiply. On 30, 60, 90s, you have two different numbers to worry about. Here's your short leg. The short leg times square root of 3 gives you the long leg. If I'm going backwards, long leg divided by long leg divided by square root of 3 gives me the short leg. Hypotenuse, I have short leg times 2 gives me the hypotenuse. If I were going backwards, hypotenuse divided by 2 gives me the short leg. So looking at number 11, that one is a 45, 45, 90. The 8, which is what I'm given, that's a leg. If I know one leg, then I automatically know the other leg. This is 8 also. And this is the leg times square root of 2. Number 12, that's also a 45, 45, 90. In this case, I don't know either leg. I do know the hypotenuse. Remember that leg times square root of 2 equals hypotenuse. Hypotenuse divided by square root of 2 gives you the leg. If you're going to divide by square root of 2, here's how you do it. You write it over that. And then, to simplify my radicals, on top I have this, and on bottom I have 2. 22 divided by 2 is 11. So here's my answer, 11 root 2. For both of these, I get 11 root 2. Number 13 is my first 30, 60, 90 on the bottom of the page here. First thing I have to figure out is which side I was given. The 30 is over here because the 60 is down here, which makes this side that I was given the long leg. So X is the short leg. So when you start with anything except the short leg, you want to go to the short leg first. Long leg and short leg, the number that relates those two is square root of 3. If I'm going from long to short, I'm going smaller. So I divide by square root of 3. Write it on top like this. The reason I'm doing that is, look, it cancels. So it's just 5. If I have 5 root 3 and I divide by square root of 3, I just get 5. Now short leg and hypotenuse are related by the number 2. And I'm going from short to hypotenuse, so I'm trying to get bigger, so I'm multiplying by 2, and there's my hypotenuse. And that is y. Number 14, this is a 45, 45, 90. I'm given a leg. If you're given the leg of a 45, 45, 90, you always multiply by square root of 2 to get the hypotenuse. Remember, the other leg would just be the same. That's number 14. Number 15, also a 45, 45, 90. I know that because it's a right triangle and the two legs are the same. Every right isosceles triangle is a 45, 45, 90 triangle. So in this particular one, I know that the hypotenuse is 12. And I'm going from bigger to smaller, so I'm going to divide by that magic number, which is square root of 2, to get to get the legs. Now I just have to write it in the correct form. 12 divided by 2 is 6. So I get 6 root 2 for both legs. Number 16, also a 45, 45, 90. Okay, this one has a leg of 16 root 2. That means this one's also 16 root 2. And the hypotenuse is going to be that number times the square root of 2. So I go 16 root 2 times the square root of 2. Square root of 2 times square root of 2 is just 2. So that's 32. So my hypotenuse is 32. Number 17 is a 30, 60, 90. Make sure you know where the 30 is, where the 60 is, to help you figure out where the short leg is. The short leg would be over here. So the short leg here is x, the long leg is y, and we are given the hypotenuse. Remember that if you don't start with the short leg, you always go there first. So I'm going from hypotenuse to short leg. The number that relates the hypotenuse and the short leg on a 30, 60, 90 is the number 2. Since I'm going from bigger to smaller, I divide by 2, and I get 48 divided by 2 is 24. Then from short leg to long leg, you always use the same number, and that number is square root of 3. If I'm going from short to long, I'm making it bigger, so I'm going to multiply times square root of 3, and there's my answer. Number 18 is also a 30, 60, 90. Number 18, again, you always want to start out by figuring out where's the right angle, where's the 30, where's the 60, etc. Okay, this is the x, y. The 6 here is the short leg. It's across from the 30. The x is the long leg, and the y is the hypotenuse. So we're starting with the short leg, which is kind of the way we learn the rules anyway. Short leg times square root of 3 equals long leg. Short leg times 2 equals hypotenuse. And those are my answer. And last but not least, we have a 30, 60, 90, where the short leg is this x across from the 30. The long leg is what we're given, it's the 14, and the hypotenuse is y. So long leg, I always want to go back to the short leg first. Long and short have the relationship of square root of 3. If I'm going from long to short, I'm getting smaller, so I will divide by that number. You cannot leave a radical in your denominator, so you're going to do times square root of 3 on top and on bottom, and that gives me this, and it cannot be simplified, so that's my actual answer, 14 square root of 3 all over 3. Then, short leg and hypotenuse, those two have the number 2 as their relationship. From short to hypotenuse is times 2. If I were going backwards, I would divide by 2. This time, I'm going from short to hypotenuse, so I'm making it bigger. So times 2. If I do this number, times 2, that's just like doing times 2 over 1, because 2 is just 2 over 1. So the bottom stays the same. Remember that if we have numbers outside the radical, they deal with other numbers outside the radical, so the square root of 3 is going to be the same. The only thing the 2 really affects is the 14. That becomes 28. And that's my final answer.